We do have an exciting panel coming up. We're moving from the war on the business front lines in Ukraine to the war that we're all fighting against climate change. We have a joint presentation from two speakers now who are working together to try to fight climate change and improve the situation for farmers. They come to us from IBM and the Agricultural Public Service Center in Rhineland-Palatinate, a name that does not roll off the tongue. Please welcome Rob High and Daniel Eberz-Eder.
Good morning, ladies and gentlemen. It is my pleasure to welcome everyone to our interesting lecture and innovation on infrastructure for promoting digital resilience and climate resilience. My name is Daniel Eberz-Eder. I work for the Agricultural Public Service Center in Rhineland-Palatinate. You are now thinking, what does agriculture have to do with the resilience of digital infrastructures? In the next few minutes, we will tell you why. We would like to put our focus on edge computing technologies. In recent months, we have expanded our use case in the field of agriculture in Rhineland-Palatinate.
There we go.
Okay, that's good. Thank you. Digital systems are omnipresent and also in use in agriculture. Why are digital systems increasingly being used? They are used because they provide added value to the user. In agriculture, the heavy use of regional sensor data will improve the knowledge base for decision making. That is why sensors are increasingly being used via IoT, the Internet of Things. The result is an increasing amount of data and data flow. There are now many digital systems and digital applications used to simplify the agricultural production. However, most of these digital systems, digital applications rely exclusively on centralized data storage in the cloud. Dear listeners, we are currently living in a time of many extraordinary crises. The Ukraine war, COVID-19, energy insecurity, climate change. In these times, we need to make our critical infrastructures more resilient in the digital domain as well. Our idea and concept for achieving resilient smart farming involves decentralized data storage based on the offline first principle. To achieve this goal, open source technologies are the key to success. Why agriculture? We now know that agriculture and food production is very important in crisis. So it is part of the critical infrastructure. We hear that before. It's a critical infrastructure. That is why we focus our concepts and developments on the resilience of digital infrastructures in agriculture. Our term for this is resilient smart farming. Based on the images, you can see different processes, data producers, as well as important geodata on agricultural production. Our goal now is to have an infrastructure that provides these data as fail-safe as possible in case of a crisis. That means reduce risks, increase productivity and increase the yields of farmers and maximize the resilience. Now, Rapai, it's your stage for you. Thank you.
Thank you, Daniel. Appreciate that. So, the things that Daniel is talking about are advantages that we can bring to many different industries, many different use cases that all have the very similar problem, which is that we must be able to process work local to where the data is being created, protect that data, and allow for that to be performed in a resilient way. We call this edge computing, and as you can see here, you can find examples of edge computing surfacing in virtually every industry that we can talk about. Dr. Deese talked earlier today about the vehicle and how that is transforming, how the architecture of the vehicle now is essentially becoming an edge computer. The ability to run some of the processes that are necessary for autonomous driving, for driver safety and security. These are things that must be run locally. And the data that's collected to perform these tasks needs to be protected. If you've got cameras on a vehicle, you don't want the images of people and other things that might be personal and private to you being collected in that data and sent back to some cloud somewhere where that data could be contravened, where the private information that contains could be intercepted. You want to perform that work locally. And that's what we do with edge computing, and that's part of what we're proposing to do for farmers, is to allow them also to perform the work that they're doing on the farm, to be able to automate the processes that the farmer has to deal with, to be able to collect the data that is needed to support those analytics, but to be able to protect that data by performing that activity right there on the farm. So when we talk about edge computing, we have a very simple definition for edge. That is, it's any computing that's being done close to where the data is being generated and where the actions are being taken. We in fact identify 3 distinct tiers of edge computing. The network operators are all going through a transformation right now to facilitate edge computing in their network infrastructure. We call that network edge. But on the farm or in the factory or on the location, we have 2 other tiers of compute that are also interesting. And one of them is sort of a traditional IT form of compute. So you might find a half rack of compute or perhaps a small appliance like you can see in the work that we're doing with our colleagues in DLR and around smart agriculture. Or it could be in the device itself. It could be in the implement, whether that's a tractor, whether that is a baling machine, whether that is a food processing machine. Those devices are also now being built with compute. Again, the example is if you go back to the automotive industry, the vehicle now has compute inside it. We don't think of that as a computer. We don't think of that as an IT piece of equipment, but yet it is still nonetheless running compute power that allows us to perform activities on the vehicle. And the advantages to each of these different tiers is a compromise between latency and data protection and reduced network bandwidth and resilience versus the economic value that you might get from having things in the cloud. What is common across all these different tiers, whether you're in the cloud, whether you're in a network edge, whether you're in a IT piece of equipment on the edge location, or in the piece of equipment that you're actually operating with, the consistent element of that is that all of them are using cloud native development practices. So we don't think about the edge as being competing with the cloud. We think of the cloud and the hybrid cloud extending to the edge. And with using cloud native development practices, we can now make the trade-offs between whether we place a piece of work in the cloud, place it in the network, or place it on the device itself based on where's the best economic trade-off between where it's located, the cost of executing it, and the needs that the use case brings out. It really facilitates this idea of multi-tier distributed computing being performed. Now, it's worthwhile understanding what's going on in the marketplace and the dynamics of how edge computing is being brought forward. There's really 2 basic motions in play here. The first of these we call the cloud out motion. And this is where the hyperscalers are saying, if you already have an experience on my hyperscale public cloud environment, we can facilitate bringing that experience out to the edge, which is fine. That works well if you already have a commitment to one or another hyperscaler. But most enterprise organizations today are really using multiple different hyperscalers. They may be using both Amazon and Microsoft and Google and perhaps others. And so they don't really even have a single experience. They have what we call a hybrid cloud experience. So the other motion that's underway is what we call the edge-in motion. This is building on the hybrid cloud experience, the ability to operate with whatever cloud environment that you have a dependence on, and if you have multiples, you can make use of each of those, but more importantly, it allows you to focus on your attention on the things that matter to your clients, to your end users, to your farmers. Solve the problem that they have, and attach that to whatever back-end cloud that you need. And so it unlocks the value that hybrid cloud brings to the table. It allows us to exploit the benefits that edge computing has without being locked in to one particular hyperscaler or another. It allows us to concentrate on what kind of ubiquity that we need to take advantage of each of those tiers as we go forward. And so things like Kubernetes and Linux have become a foundational framework on which we can build this kind of portability. And then we layer that with management capabilities. Now it's important to think about the management problem here for a moment, because while we are leveraging cloud native development experiences and bringing those advantages of the cloud out to the edge, by the same token, the edge is not a cloud. There's very significant differences between the two environments. In the cloud, we're trying to deal with elastic scalability over virtually infinite resources. The idea that I can build and deploy a workload and not worry about how much compute resource I'm having to deal with allows us a great deal of advantage when we're in the cloud. But to be able to accomplish that, cloud providers leverage homogeneity. All of the compute capacity in the cloud is the same. It's all monolithic. It's very large scale. There's very little diversity, there's very little dynamism other than the scaling of the compute capacity that you need for that workload. At the edge, you have a tremendous amount of diversity. You have different pieces of equipment with different architectures. You have different purpose at different farms or different locations. You have customizations that you need on an individual farmer or user basis. That diversity has to be addressed. There's also a lot of dynamism. Tractors on the farm move around. They may be located on one side of the farm today and a completely different side of the farm later on in the afternoon or tomorrow as the farmer performs their tasks. They may move from farm location to farm location. The jobs that they're performing vary throughout the day, throughout the month, and certainly throughout the season, and that dynamism has to be factored in for the workloads that we're performing there. Thirdly, we have a very different attack surface out at the edge. We don't have the benefit at the edge like you do in a data center or a cloud data center where you've got walls and armed guards and cameras and alarms to protect the equipment. Out at the edge, this stuff is in the wild. There are people walking around it. There's the ability to attack these surfaces in ways that you really can't in the cloud. And while on the one hand, that may represent a disadvantage, on the other hand, we can manage that and actually bring that to be an advantage, because when we distribute work across the edge, we're creating many different locations that you have to attack. To have a successful attack, it's not enough to attack a single central location like you might have in a cloud. At the edge, every separate edge component is a separate entity. And if you want to launch a successful attack, you have to attack every one of those components at the edge. So that actually provides a much safer environment. And as I indicated earlier, the data that you're collecting, you want the farmer to have control over that. You don't want to give your data to somebody else, some other cloud provider. You want to protect that data. That data may have information that's important to your plant, your farm operations that you don't want anybody else to know about. And so you want to protect that data in your local environment. And that's a big part of what we're able to do when we're talking about the edge. So diversity, dynamism, the security issues, these are all things that we have to deal with at massive scale when we're working at the edge. And that's a big part of what we've been focusing on in a project that we have formed in the open, at the open source organization called Linux Foundation, the LF Edge Open Horizon project is designed specifically to deal with these kinds of management problems at massive scale, to protect the workloads, to make it very secure for how we deploy workloads there, how we protect the data there, how we get the right workload to the right place at the right time, and do so at massive scale. So I'd encourage you to take a look at this open source project. This is what we've embodied in a product that we call IBM Edge Application Manager. We're lending that for use in this project. We think that this is going to have tremendous benefit, again, for agriculture, for sustainability, for safety, for productivity on the farm, to make farmers better at what they do. But again, this is something that can be replicated and adapted to virtually any other industry, whether that's manufacturing, automotive, retail, industrial, distribution, supply chain. All of these are opportunities for us to take advantage of compute capacity in the local environment to benefit the AI and the other processing that needs to be performed locally around data that could be protected in that environment. So I'd encourage you to come back and see the work that we have going on. We have it demonstrated in the IBM booth at the back of the building. I also encourage you to reach out to both the AgriRegio website, where we're doing this work together, as well as I've also included more information about Open Horizon, as well as the IBM Edge Application Manager that we're using for this project. And with that, I want to thank you. Daniel, thank you so much for your partnership.
Thank you.
It's been great. And thank you so much for having us here today.
Hey, thank you both. It's always nice to see government and industry working together. That was fabulous. Are you guys taking audience questions? Because I think we have a minute.
We have a couple minutes now, and
Yeah?
we'll also take questions later upstairs.
Okay, so I know it's hard to be the first person at the conference to ask a question, but we do have a microphone set up here. Who has a question? Yes, you, sir. Please go to the microphone. Thank you for your bravery. It's just behind you.
Hi, Rob. My name is Mario Bienemann. We met us in London some years ago.
It's been a while.
Okay.
Yes.
What do you think about the smart city development of the telemanagement forum? Should be integrated into that edge problem, I think so.
Yeah, and so whether it's in automotive, which we've talked about previously, or whether it's in the intelligent roadside that those vehicles are connected to, or whether that's in the intelligent city around city planning, traffic management, citizenship, it's the infrastructure and the facilities management in the city. All of these are opportunities for us to take advantage of compute that may be embedded in the road or the roadside. It may be embedded in the network infrastructure that we have in a city, or there may be locations throughout where we can collect information and improve the efficiency with which we get traffic moving through a city, or where we are able to protect citizens from crime, whether we're able to protect their safety and security, or just simply provide better facilities for some of our social infrastructure as well. All of these are great opportunities. Of course, we have to protect the data, and that's important too. So I don't want to diminish the importance of that in the context of how we bring compute to that data. I will argue one more time that the less movement, the less often that we take a piece of data and move it from here to there to be processed, the safer we can make that data, the more we can protect that data.
We extended the program at the moment to the smart society concept. That's a new thinking model. Here in Germany, you have the task of the cities and the towns to develop the so-called kommunale Daseinsvorsorge. The tasks, what they have to do. That means energy, telco, healthcare, food, and. And then you need, I would say, an edge-based network with defined interfaces, private and secure.
Yes.
And it's the first starting point for a new, I would say, initiative we call the new Hanse. if you're familiar in Europe, there is an old, I would say, connectivity between the towns on the Baltic Sea. It's the Hanse. But very successful. Today we have it on the plates in Germany. The A for Hanse. And now we are talking about a digital Hanse.
Well, that sounds really exciting, and it also sounds like a conversation we could dive into even deeper in the Speakers Lounge.
Yes.
If you don't know where the Speakers Corner is, it is up here with these green plants. Rob and Daniel have both kindly agreed to make themselves available there, so please take your questions and conversations. A final round of applause for Rob and Daniel. Thank you very much.